Okay, hello everyone. This is a Wolfram Language Design review about how we are setting up our assessment framework for math expressions and the question of when is x squared minus 1 considered equal to x plus 1 times x minus 1 and when is it not? Is that a fair summary of what we're talking about here?
Yes, that is. Yeah, right. So we've had this assessment framework for a couple of years, but mostly it's kind of relied on exact matches in like a multiple choice situation or sort of unambiguous matching. But since, we're kind of very well positioned to do more complicated stuff surrounding math.
Right. The problem is that at different levels of math, I mean, to a calculus student, x squared minus 1 is equal to x minus 1 times x plus 1. But to an algebra student, they're not supposed to be considered equal.
Yes, that's right. That's right. So if we're just calling it math, we need to support all those cases.
Yep.
Right.
Okay.
So from I have this demo notebook that's kind of working at a very high level, and then we can get into the weeds as we move on. If that works. So, you can do some like question object and you can, put the answer in here, and we support things like tolerance, where just the total difference between the answer has some acceptable tolerance on it.
So hold on. People are not using slide rules anymore, are they? A slide rule, right? You have to read off the numbers, and you might have a slight mistake.
Right.
The only way people are going to have different things is if they're using like a calculator or something, and they didn't type in as many decimal digits. But otherwise, I don't understand how they would get 11.001.
Right. So maybe they're using a calculator. Right. So yeah, the idea is not necessarily that the student is solving these in Wolfram language. It's that it's the teacher's tool and they're presenting the notebook, and the student solves it how they solve it. And you might have a question.
I understand that, but I'm disputing for an algebraic case that numerical tolerance makes a lot of sense. By the time it's algebra, they're probably not doing approximate numbers.
Okay. Well, I mean, if the coefficients here were approximate, maybe it makes.
Why would they ever have that? Nobody does that, do they?
I don't. Maybe it's an engineering class where they're read from some table in some book, right?
All right. Okay.
Engineers have tables of approximate numbers.
I think. Yeah. Okay. Fair enough. Okay. For example, do we have unit matching? Do we know? If somebody has a same type of thing, if they say joules versus they say kilograms, meters.
Yeah, that's been built in for a while. Yeah, we have
do we automatically convert, or do we have the same kind of thing? Because I can imagine. Okay, but let me make a comment about that. It's the same deal. To some people, joules and well, it doesn't matter. You don't need to write it out. It's kilogram meters per second squared.
Okay. Yeah, we can do control equals, right?
No, I'm not sure that's the wait. Hold on. For example, kinetic energy would be mass. Yeah, it would be mass times that squared, all squared, meters per second, all squared.
Okay. I can't mouse into it.
I think you can. Just click it. Just click it. Oh, not after you accepted it. You can't.
Yeah.
Can you do that? I'll try it. Yep. Okay.
Right. I mean, unable to. That's strange. I don't know.
With the search points, what the hell is search points? Quantity. Hey, you've got weird error messages there with nearest.
Well, I mean this. Oh, because I did. Okay, search rate. Well, that's
what the hell is that?
Okay.
Bug.
That's a bug.
Crawled out.
Got it.
Why do you have to do a tolerance for a quantity? I don't think you should.
This is a bug. This is definitely a bug in the quantity sampling. You shouldn't need to do a tolerance, but it accepts it and it does.
Okay, but you could but you should be able to do a tolerance that is a pure numerical tolerance, which will be the numerical coefficients. You get what I'm saying? Just like it is in the algebra case. You're not saying.
There we go. All right.
Okay. We'll put in a 5 there. Put in a 5 as the quantity, as as the thing you're assessing to.
Oh,
Okay, fine.
that just happens. Yeah. Oh, I guess they're equivalent. Yeah. All right.
Okay, but hold on, stop for a second.
Sure.
Whatever framework we can give for the equivalence of algebraic expressions, we've also got that for unit expressions. We've also got an issue for unit expressions. Do you understand what I'm saying? For some classes, joules are the same as that kilograms, meters squared, blah, blah, blah.
I see.
But for some, they are
Yes.
not.
Yes. Right. So, what we've had for a while is a quantity comparison method with an assessment function, which assumes that you want to automatically convert quantities.
I know. So I'm saying there's probably a case where we don't want that.
Right. We also have like that where it could just be like a held expression is a comparison method that we have that.
Okay. Yeah, fine. But that's too detailed. I'm just saying, I'm just flagging this as another thing. But let's keep going on the
right. So within math, what we're looking at today is, you have your answer key, and then you have math expression is what we have it named right now that we can, and then within this we have a method option that is going to allow all of this, customization.
Okay.
And so right now we have two primary methods: match, what we've called match, and what we've called equal.
By the way, do we have people from the Wolfram Alpha math team here?
No.
We probably should. Yeah. See if Bradley, maybe? I don't know. Who? Because what I'm going to say is, even a communal garden LLM now knows things like what 5th grade math is about.
Yes. We can talk about LLMs if we want. I have an example that we can get to later.
Okay.
Right. So that we have match, which eventually feeds into match Q, and we have equal, which eventually feeds into double equal.
Okay.
And those are the equal
match
one.
Q of the unevaluated expression or match Q of the evaluated expression?
By default, unevaluated. We have sub options that let you control that evaluation, and you can customize it on and on. There's sub options here that get into the weeds, but we've tried to make the default very sensible. By default, when you're working in the match method, it's unevaluated. Everything is either inactivated or held, right? So here's an example.
Can you give me big picture of my x squared minus 1 example? How do we deal with that?
Right. So if you have, I'll just do assessment function of x squared minus 1.
Yep.
X
squared minus 1.
Right. So that's by default going to be considered math, right? We have some heuristics that look at it and say it's math.
Okay.
So we do end up on this framework automatically. And by default right now, and this is something that we want to discuss, it's going to pass. Is it? Am I doing this right? It's going to.
Okay, so now put an expand. Copy down. No. Leave that. Copy it down. Put an expand on the right-hand side there. No, not there.
Right.
Okay.
So, Chris, is this going to match by default then, or is this going to? Oh yeah, this is going to equal by default. But even the double equal thing. Oops, x double equal y. If one polynomial is expanded, one is factored. It doesn't give true.
It equal.
Right. So that's what's happening here is it's getting passed to something like this, and it's not determining that it's equal, so it's giving incorrect here.
Okay.
Right, and there's two main sub options that we've introduced. What we've called inactive pattern, which isn't the most beautiful name, but it tells you what it does, and something we call transformations. So inactive pattern lets you control what evaluates and doesn't. Basically, whatever you put here gets passed into the second argument of inactivate. So it's heads, there can be alternatives, there can be accept. I know, but people on the live stream might not. So you can very much control the evaluation. So, maybe the only thing you don't want to allow to evaluate is the multiplication between these terms, but the pluses where the minus signs are, you can allow, or, so it works out. So you can reorder terms here, but you can't expand terms, that sort of thing, and it'll be correct. Right, here's another one where we've inactivated power. So, the division evaluates, and right. So, and then the second main option here is transformations. And these get applied in the case of equal, they get wrapped around the entire equality, right? So you have, transformation one.
So it's f of 1
X.
equals f of 2, basically.
No, it's f of x equals y, which is important. Because even if you have like the factor polynomial and the expanded one, if you do simplify on both sides, it might not end up in the same place. But if you do simplify around the equation, it's gonna
really
find it. Yes.
Okay.
Yeah. Danny Finn pointed out a great example to us early on of that exact use case. So we decided that the transformations in this case apply around the entire quality. In the case of the match method, the transformations are applied to each half independently. So, the transformations for the equal case are much easier to come up with because they don't have to like operate through a hold generally. So you can use normal things like expand, simplify. In the match case, you can do things like replace, and that works just fine.
Yep.
But we've also come up with some named ones that we haven't documented yet. But we think this idea of the shorthand name transformations.
Yeah, I agree. Okay, let's get to the end of the agenda. Let's come back to this. What's the next thing you're going to talk about here?
Okay. Here's an example of one that came out of ChatGPT. So we can keep going into sort of lower level details. Do you want to get into that?
Okay. No, I think I'm understanding that you have a concept here of equal or match.
Exactly.
Why isn't it called same Q versus equal?
Well, it's not passing to same Q, it's passing to match Q. We can support things like blanks. You can do a hold of X plus blank.
Why the hell would you want that for math?
Oh, I mean, you don't necessarily want, imagine an indefinite integral where there's a constant and you don't necessarily need to use the big C. You can use anything, right?
No, you can't use anything because you could put an X in there and you would have the wrong answer.
Well, maybe you have a pattern test.
No, nobody's going to do that. Okay, let me ask a meta question. All this stuff, have you talked to the folks like Bradley here who do math content?
Yes.
Who'd you talk to?
We've had multiple meetings with Bradley. And
okay, fine.
Yeah.
Okay. Because the thing you just said is a non-starter of plus blank. It's just wrong. Some kid is going to write plus sine X.
I think a sophisticated teacher could come up with good pattern-based
Yeah,
tests.
They're never going to do it. If we do that, we want a thing called indefinite integral. It's just a string name, but we've done the right thing. You see what I'm saying?
Yeah. That totally is the sort of thing that we're planning on. Yeah. We don't.
Right, because integrals are kind of complicated because they can have a constant difference, right?
Exactly. Right. So yes. We haven't specifically talked about an indefinite integral one, but that's the sort of thing we want to build out more.
Okay. I think the blank thing is a non-starter. I think.
Right. What do you think the advantage of same Q versus match Q is?
I don't know as well what match Q actually does. I mean, same Q is a well understood thing for comparing expressions. I don't know what match Q does with numerical precision and things like this. See what I'm saying? I assume it uses same Q, but I don't know. Which is kind of embarrassing after all these years. It's never come up to me. Match Q has never come up as a thing trying to match approximate numbers for me. I don't think ever.
Chris and I definitely discussed same Q versus match Q, and we decided that we might as well support patterns, so we might as well use match Q.
I think
But
it's
if-
offering
if
people
we
too
c-
much freedom that they don't need. I mean, you
We-
could support match Q as well. You could support all three.
We could.
I think that makes more sense because I think
Yeah.
it's now the question. Okay, so let's walk through what the issues are. Okay, issue 1, is it held or is it not? Issue 2,
Yes.
how do you do the comparison? Is it same Q, match Q, whatever? Okay. Issue 3, what transformations can be run, either a single one or multiple ones, on either the full, there's no point in running a transformation on a same Q because the same Q is already blown up by the time the
Yes.
transformation
Right.
happens.
Exactly.
But there is a point in potentially having, F of blah, same Q to F of blah.
Right. That's
You know what
yeah.
I'm
We'd
saying?
have to do the transformation that way within same Q.
Right. But okay. So let's just walk through. I mean, did I get all of the options here, all of the different cases? Or are there more cases?
Right. Well, we have the tolerance, which we can discuss. Yeah.
No, I know, but that's part of that's something that will be fed into the comparison function. Like, does match Q take a tolerance? You can look it up. I don't know.
Oh, I don't think so. No.
Well, that's complicated and weird. And I don't know why it doesn't. I mean, yeah, I don't know why it doesn't. I would have
Is it
thought it would have the
varargs? I
same
think it's
issue.
varargs. So options.
No, I doubt it's varargs.
No, there is no tolerance in match Q. No.
But does it use same Q or equal for its way of comparing numbers? I bet it uses same Q. Does same Q have a tolerance?
Maybe some.
Well, why don't we just look
hidden...
it up? Bring the documentation up. Does
For
same Q have a tolerance? Yeah.
It has the same test, I think. I don't know if it has a tolerance.
Oh, it's varargs as well.
Yeah. Oh no, it doesn't even have same test, does it?
No, it doesn't.
Okay. Yeah, it's varargs and it works on rules. So
Right.
Yeah.
Okay.
Okay.
So did I capture all the major issues?
Yes, you captured the major issues well. Yes.
Okay. All right. So let's go through these then. All right. I'm not keen on the way you've done this with the sub options for methods and so on. To me, I mean, isn't assessment function, doesn't it usually have a second argument, which is the assessment method?
Yes, which can be inferred, and that's what's happening here, but it's the same as putting math expression. We definitely considered, instead of having this method value, having a math match and a math equal and a math same.
Well, I think that is way too complicated for most of our users.
I thought so too. I thought, yeah, having this with heuristics that usually get it right is better.
Is math expression, is that second argument annotatable? Do you have other things where there's like a list there? Or
Not anything? Well, it can be a full association where that becomes a thing that's comparison method.
What are the other?
Element-wise assessment goes to true, where it treats a list as a bunch of different answers. I don't know. We can look at that. You can specify a custom comparator or how to combine the scores when you have multiple parts. Right?
Yeah, okay, right. I remember some of this stuff.
Right.
Okay.
These
All
things.
right. Go back then to the other. Go back to this case. Okay. So, and this is perhaps a Bradley question. If you just look at the math hierarchy, so to speak, in first grade, third grade, fifth grade, I don't know what, right? Is there a way in which the equivalence of math expressions gets ever looser, so to speak? I mean, 4/6 is not the same as 2/3 when you're learning fractions.
Correct.
But later on, nobody really cares. I mean, somebody might say points off because you gave 4/6 in the answer to your integral rather than 2/3. Would they say points off for that, or would they not?
I feel like at like the calculus or the university level, you stop getting points off for things like that. I don't know if AP Calc in particular would mark off. Probably they would mark off for things like that.
Okay, fine. But then we've got some waypoints like the AP Calculus rubric, like, you know, we got these various rubrics. Seems to me that's what we should be concentrating on. If there are rubrics for this, you know, have a version of MathExpression that says, you know, MathExpression AP Calculus or something, comparison method arrow AP Calculus, comparison method arrow, you know, I don't know, basic algebra or something. I don't know, or some class name or something like that. Because each one of these things, there's going to be a lot of complicated stuff of whether, you know, you can consider.
Right. I thought we would have a bunch of things as, you know, just here AP Calculus within MathExpression as opposed to a different comparison method.
Possibly, yes.
And it also depends on the problem type, right? It's, you know, a lot of the problems are, you know, write this in a particular form, in which case the expected form is very strict, right? If it's a form of a line equation or a form of, you know, mixed number of a fraction versus a improper fraction, things like that.
What is a line expression? Did you say a line expression?
Like point slope form of a line,
wow.
whereas y equals mx plus b versus
the amazing thing is the way that the jargon of all these different forms has evolved over the last 50 years or something. Anyway, that's just my amusement. But then let's say you're looking for the point. What did you say? The line form of a thing.
Yeah, point slope form of a line, or standard form of a line.
Okay, point slope form of a line. So let's say you're looking for, the answer is, you know, 4.4,27 or something, and that's the thing you're looking for, right?
Okay.
Well, I mean, then
is the point slope form an equation, or is it's just a pair of coefficients? What do you think?
I'm sure it's a point, which means an actual XY coordinate, I would assume.
I see.
So, right, point slope form of a line is that the line equation, the y equals mx plus b, and it's that particular equation.
Okay.
All
right.
Yeah.
Fine, but my point is here that, so if somebody said, you know, u equals 5v plus 3, that would be a no, right? You don't get to do that. Is that correct? You couldn't use any variables other than x and y. True or not true?
I think sometimes true, but the problem statement would typically be, you know, use x and y or use u and v as the variables.
Okay, but I mean, basically the issue here is there's a lot of kind of content knowledge in, oh, it's an indefinite integral, but you know, like for example, okay, so here's an example for an integral, okay, it's a Mayer G function. Well, actually it's just sine squared x, but I give it as a Mayer G function. Am I right? Am I wrong? It's mathematically equal to most calculus teachers. The Mayer G function is not considered the right answer. But why not in our formalism, so to speak? Probably full simplify would say it's equal to sine squared x. Am I making sense?
Yeah.
You don't need to look it up.
Okay.
Right.
I mean, many integrals can be done very, very mechanically in terms of Mayer G functions.
Okay.
Right.
When I used to be in the business of doing integrals, I don't know whether I haven't done any test type things after I was really quite young, so I never had the opportunity to hand in you know, here's the answer. It's a Mayer G function. I didn't know about Meiji functions. The hypergeometric functions, what I would have said in those days. And you know, it's kind of like, so I never did the experimental test, so to speak, but it's certainly exotic. And you know, but the whole point is those things are deeply mechanical. So you need to know a lot less to say the answer is this as a Meiji function than you need to understand how to, you know, translate it into sines and cosines and so on. Okay, so my question is, if we were to take various rubrics for things, AP Calculus, this, that, and the other, how many of these are there, do you think, Bradley?
Oh gosh. I mean, the College Board stuff is probably the best one for the US. I can't really speak to the
Okay, the Gaokao. Who
international
knows what the
community.
Gaokao does? You know, we don't know.
Yeah.
Somebody probably knows.
But I know that AP like grading heuristics specifically mentioned things like radicals in the denominator of a fraction and things like that. So
okay, so we would have a fighting chance of being able to, I mean, to me, one of the things that's complicated here and that we could potentially handle well is whether you got the right answer but not in the right form. And we have a way of specifying sort of partial credit, don't we?
We do. Right now, the assessment result object always has a Boolean correct value, but it also has a score value that can be anything. And you can pass back an explanation that's presented to the user.
All right, but I mean, to me, this is a really, you know, we got to ask educators and things what they need, because I don't know. I mean,
right.
You know, for me, the hypergeometric function is the right answer as far as I'm concerned. It's not the best answer, but it's a, you know, now in terms of let me think for a second.
Right. I mean, what's great is if we have
any choice. Okay, we may be able to have some El Cheapo things. I think they will not be widely understood. I think the only way to do this for real is you know, an actual content specific, curated rubric XYZ type method. And I would even, I mean, I think, isn't the term rubric a fairly common one for describing, you know, what's considered acceptable and what's not, that goes beyond the just right answer, wrong answer? Or is that not correct? Somebody education oriented respond to that, Bradley, perhaps?
I don't know what the official term is.
Okay, we should find that out. We have plenty of people in the company who know this stuff. I think you guys should do a meeting with some of the folks like Alec in the UK and all kinds of people who know about this stuff. I do not.
Okay, we can set that up, right, Avery?
Right. I mean, and then what you want to ask is, okay, so for what you're doing right now, I mean, I have no idea what heuristics is MathExpression using to determine equality.
Right. I mean, by default, it's, you know, inactivating local symbols and sending it to equal.
Just to equal, not to full simplify.
No, that if you can do transformations, goes to full simplify if you want that.
People are not going to understand that.
But, you know, one of these named methods we have is simplify, that it will do that. Right. It's just a convenience on top of equal. We have a doc page for this, by the way.
You want full simplify, I think.
I mean,
by the time you do, I don't know. In some cases, full simplify is going to blow up your exercise, right? If you say, is sine 2x the same as 2 sine x cos x? People, you know, I mean, this is why the only way to do this, in my opinion, is, I mean, okay, one thing we do not have is all the possible mathematical transformations that we can do. We don't have a big list of them. I tried that actually in S&P in 1980. People didn't find it very useful. Maybe the world has changed and they find it more useful today. Of just saying, these are all the transformations, you know, number them, label them, you know, which ones do you want to apply? Okay. So, but Bradley, do you want to comment some more on what you think should be done here?
Most of my familiarity with this stuff is through working on problem generator. One thing that we did there that I'm not seeing here is a atomic test, and not capital A, atom Q or anything, but we checked to make sure that there weren't symbols like integrate or Meyer-G or things like that. So
Right, that's a good
Right.
right. Okay, you know what? The basic bottom line here is this is going to be a big heuristic mess, and we shouldn't pretend otherwise. And we should provide content-dependent, names here. So I don't even think MathExpression is the right concept for a comparison method. It's not a comparison method. It's a type of thing. I mean, mathematical equality would be the right thing to call it if that's what we were dealing with. Well, which is what you've said, math equivalence over there.
Yeah.
For the method option. I mean, comparison method, math equivalence is a reasonable thing to say. And math
I mean,
equivalence.
other comparison methods we have, if we want consistent grammar, are mostly nouns. We have things like quantity and geoposition. And
I see. Okay, well, fine. Fair enough. But then I think MathExpression should mean we try as hard as we can to find out if these things are equal, which means we use full simplify, we do all these kinds of things. And everything below that is some kind of rubric for some particular educational level and so on.
Okay.
Look,
right. I mean, choosing defaults
even
is certainly hard. If you think the default should be heavier weight, I don't have an argument.
I think the default should be, is the thing mathematically equal? I think, I mean, because I don't really see, other than, it then comes down to specific operations, commutativity. Do we include associativity? Commutativity, 2 plus x is the same as x plus 2. Okay, we believe that. Right. Now, what about associativity? You got extra parens in there.
Right.
I don't know. I mean, for some, 4 over 6 versus 2 over 3. Are they equivalent or are they not?
Right. Commutativity, for the match method, Chris did work to make that work for things that are orderless expressions.
Yeah, well,
right.
Maybe. I mean, it's a total mess, right? I mean, to me, it's like, is it mathematically equal? Which means we try as hard as we can. You're doing a class in control theory or something, and an unevaluated integral will be considered okay, perhaps.
Right.
Get what I'm saying?
Right. Here's the convex optimization problem. I'm done. Yeah, those things.
And I think for it's calling it math expression. I mean, maybe we should say, maybe we should break that more into algebraic expression, because I can see not wanting to do transformations. I think it is a more advanced kind of math where you're doing, let's say it says algebraic expression where it's algebraic equivalence. Okay. That means you're doing, I'm not sure if it's a comparison, algebraic expression. Yeah.
Equivalence, you said.
No, I said, I mean, if you're using nouns, you've got to say algebraic expression. But that means you're not allowed to do sine 2x goes to 2 sine x cos x. Right? That just means I mean, conceivably, there's an arithmetic expression, algebraic expression, math expression. Okay, an arithmetic expression, what does it do? It doesn't do, algebraic expression would take sine x squared minus 1. It's the same as x minus 1, x plus 1. arithmetic expression, I don't know. I mean,
I think it would inactivate everything except a small family of symbols and then feed it to equal and wrap it in simplify or full simplify.
Bradley, what do you think about this?
I think this is the right track. Again, with problem generator, we have specific kind of answer checking parameters
Right.
for different problems, right? So we have one.
You
for
know the entire
polynomials.
universe of problems coming in. which
Yeah,
are-
essentially, we know, right?
Okay,
So we
what are the options there? How many are there?
Dozens, and some of them rely on each other, right? I mean, there's problems that expect an integer that's easy, that's simple. There's ones that expect a particular form of the fraction. So there's 2 or 3 of those. There's ones that expect a particular form of a polynomial, like the factored form or the fully expanded form, which are, different heuristics for each of these. So there's lots of them, but it's very problem specific, and I don't know how to generalize that until you get to like the algebra level or the calculus level.
Well, the problem specific ones, remember, these are specific problems that we have here. So people can, if they know it's supposed to be 2/3, they can just say it's supposed to be 2/3. They don't need to do any fancy, but the problem generator is different because it generates problems. So it doesn't know. It doesn't know what the answer, you get what I'm saying? Whereas here, the teacher can figure out, oh, I think the answer is blah, and put that in.
Right.
So I think the problem generator is a more extreme case. Look, I think you guys need to go back to talk about math content here. I think, my external view would be that arithmetic, algebra, math are perhaps reasonable levels where math means, your calculus and above. I think you're going to need specific things for things like indefinite integrals, where it can differ by a constant.
Right. Yes. So you think this differentiation between arithmetic and algebra should happen at the comparison method level and not at the method option level? Yeah.
I think so, because people really want that. I mean, they
That
know they're
seems-
teaching
yeah.
an algebra class. And, it's a big thing. They don't want to be filling in a method option every single time for every single question.
That seems reasonable to me. The line there is blurry about what should be a comparison method and what should
I
be.
agree. But I think in a first approximation, if you are teaching a particular course, unless you are making a very specific point, you should be able to use a comparison method that is somehow keyed into your course. See what I'm saying?
Yeah, that's a rule of thumb that makes sense.
Right. So I think we need to iterate this. You need to go ASAP, talk to a bunch of people within the company who know about these different courses. I mean, I don't know who's done, I know we've done a lot of stuff matching to grade levels and common core standards and things like this. Whoever's been involved in that will be a good person to ask about this. Okay. Then I think you gotta code up I'm gonna say pick like 5 rubrics. Okay. And maybe we make a rubric up that's, like algebra class. I don't know what grade people do algebra in. I have no idea. 5th grade. I don't know what grade do people do algebra?
7.
Okay, I wasn't so far off. I was only off by 2 grades then. Okay, fine. But define math levels, algebra, calculus, whatever, arithmetic, and have comparisons appropriate for those levels, I think, and try to have the general case of those, and then maybe there are special casing for people who are, teaching a very specific, class, et cetera, et cetera, et cetera. Make sense?
Yes, I think that that's still falls into this framework. I think all of these things are basically still
Yeah.
going
They're
into
fine.
the
I mean,
controlling
there's no-
evaluation, applying transformations.
right. So, okay. So let's just look at the do-it-yourself approach.
Right. So this is the do-it-yourself approach, right? Do we want to stay on the demo, or do you want to look at the doc page that we've?
No,
put
let's look at
together?
the documentation page.
Okay. So this is a new kind of documentation page for comparison methods.
Good.
Where this is the biggest one. All the other ones are pretty simple.
I think this is wrong. I'm sorry. I just think you should break this up. I think by the time it's a math expression, we just, kind of know what we're doing. By the time you're talking about, equal versus same Q and so on, it's not a math expression anymore. If it's a math expression, we're expecting it's an equal comparison, blah, blah, blah. If you want something different from that, I think you want to call it a symbolic expression or something.
Well, but I mean, there are a number of these. It's useful to use match and apply transformations that are specifically designed for mathematics.
Fine,
right?
but you don't
like
want all of these different
associativity or
cases.
commutativity.
No. Look. Okay. Look. There is a function which generates a canonical form, either of the left-hand side and the right-hand side, or of the combined equality. I don't know whether it's useful to do it the combined equality. I don't know whether our functions actually pay attention to that, whether full simplify basically maps across the two sides. Do you get what I'm saying? I think it maps
does.
across the two sides.
No, it does the full expression on inequality.
Okay, well, fine. But then that's so, so those are the two cases, it seems to me, is either you're doing, please check that with somebody who really knows, because I don't think that's right. Okay, I don't think it looks separately, it looks at the two sides together, but I might be wrong. Okay. But the more common case, and what I would do is just say you've got an equality expression with a double equals, not same Q, right? Just double equals if it's math.
Right.
You can provide a function, which is the thing to bash that with to try and resolve it. End of story. Just a function. You can provide full simplify. You can provide whatever you want. No quoted strings. Just there is a canonicalization function, and maybe that should be an actual option.
Can you hold or inactivate?
No.
Sub-expressions?
Why would you do that?
Well, otherwise students can just pass in the question as the answer. They could just give code and it'll evaluate.
Well, that's what you have to do when you say math expression. You've got to inactivate all those things. That's what it means to have a certain level. Maybe that's the definition of math expression as opposed to symbolic expression. Maybe symbolic expression is whatever it is with the bashing function, with the canonicalization function there. And if you say math expression, it will deactivate, it will inactivate everything that isn't math, everything that isn't resolved math, if you understand what I'm saying. Right, so inactivate integrate, inactivate factor, all those kinds of things. Right, just don't inactivate the mathematical functions, the numeric Q, numeric math, and some other non-numeric mathematical functions. Does that make sense?
I understand what you're saying. I'm sure that there are counterexamples to why that's going to fail. But I'm not coming up with them at the moment.
Okay, but that's my suggestion. Inactivate everything that isn't math. Yeah, there probably are examples. Michael would be a good person to ask for that.
Right. Functions that you're thinking of as mathematical functions that you don't want to evaluate because it would ruin the question.
Yeah, fine. Whatever. I know there are going to be exceptions, right? We're going to give people various rubrics, and just like, a code of laws or something, people are going to find loopholes.
Right. But I think we want to keep this do-it-yourself open framework that we have here.
I think it's too complicated. I think it's not the right thing. I think you should give a comparison function. It's either equals or it's same Q, whatever, and a canonicalization function. In fact, the whole thing that could be wrapped together. It's just the essentially assessment function, which is either full
I think the only
simplify
difference
and
between that and what we have is that we also have the inactive pattern option, which I think you need.
what is an active pattern? The thing that
So before it passes it to the test function, it calls inactivate with whatever's here around.
yeah, but I thought we were agreeing
things.
that there will be a bank of those things for math expression.
I think I think we can come up with a collection of named.
Yeah, but then you're going to want to
things
both
that you can use.
activate or inactivate those with respect to those names. See what I'm saying? You could say, oh, but for my particular class, I want the binomial coefficients to evaluate.
Right, but I also think we should have one that's just open and you can specify things directly. I
Right,
don't
but
think we
you
should
gotta
force
specify-
people into named classes.
I know that, but
Okay.
look, they're not going to think of which things you have to inactivate. Okay, they're going to get it wrong all the time. Do I have to do subtract? Do I have to do minus? Do I have to do this? Do I have to
agree.
do that?
Yes,
They're not going to get it right. It's quite complicated.
it is. Yes,
So
but I don't think we're going to get all the classes right either.
right, but so I think we should just punt completely on this. And if they want some detailed inactivation thing, they should just write code to do it. And there can be a function repository entry for some specific case of a class about binomial coefficients or something. And that's how it's going to work, rather than us trying to partially do it and have people use inactive pattern on things where they're going to get it wrong, and then they're going to be unhappy. I mean, I think it should either be completely, you get to do the comparison, you write the comparison function. These are not incredibly complicated, these comparison functions. I think having, either that or it's completely kind of, we babied you and we did it for you with a named comparison. Those are the things I think we should be doing. And I think we should be clever about the named comparisons. Now, whether those named comparisons need sub options, I do not know. That depends on details about math education that I don't know. Make sense? I mean, what do the CBM guys do? What have they done for math expression comparison?
I don't know. I don't know that they have
They do. They
a
do.
lot of free-form math inputs. Do
They do have math inputs.
Okay.
So I think this, I'm sorry, but I think, it's what happens in these design reviews. I think this didn't go quite in the right direction. I don't think you want these weird, complicated sub options. I think you either want, we're just going to do the right thing, math expression, algebraic expression, whatever else, or it's pure do it yourself. And I just don't believe, I'm sorry, I just don't believe in these partial things. These partial things may be super useful for us to implement, algebraic expression, for example, but that's on us. And, I think that's what we have to do. Either people use the things that we've created, or they write their own. And possibly we can put in the documentation page, we can put the code that's used by our comparison functions, possibly, if people find that useful, and then they can just modify it, take out a transformation, add a transformation, and so on. Does that make sense?
Yes.
Okay. Anything else we should make sure to cover? I'm afraid this is going to have to come back another time. So please work with the people who know math content stuff.
We have. We've done plenty of collaboration.
Okay. Well, I'm afraid it needs. I think I gave you an outline. Unless you violently disagree with it, I think we should wrap up here.
Okay. The other people, Chris, Stephen, Schroeder, Avery, have questions.
No.
I just wanted to say that probably with the low level development that we have done here, we can answer all these specific problems. So that was the point, actually, to say that having this inactive, having this transformation, we can build a specific answers for.
That sounds good to me. Right. The point that
Yeah.
I'm making is I don't think this intermediate layer is terribly useful to users. I think either the complete do-it-yourself, where they understand they can write code, or where we've given them a fully babysat version of, I think those are the two useful endpoints. I think this intermediate one, where people look, just to explain this, you know, anytime people have to understand a new sublanguage of, you know, a whole nest of options and so on, that's asking a lot of them. And it's only worth doing if it really has really high payoff relative to they just learnt the generic Wolfram language story, and you know that's where they go. Okay, what's this LLM?
But we only need to teach it to one person. We only need to teach these sub options to the LLM.
Yeah, right. Well, it won't get them. It won't get these. It's a long
Right.
training path.
Right.
It's got to have lots of examples. It's just not worth it. I mean,
right.
it's going to have a much better chance of writing the generic code
Okay.
than it is writing anything with these sub options. It's never going to learn it. It's not going to learn.
I understand. I understand what you're saying. I don't think we have to throw away code. I think very much what we have we'll be able to use to do these things. I think we'll have less documented in 13.3, but we'll have better stuff when it does get documented.
Right, but let's try and work as quickly as we can to get a few rubrics that we can document. Okay.
Sure. Yep, that makes sense.
Even if they're experimental, and even if we find, oh, there's a loophole here, we have to change this, etc. Right? I mean, you know, I think, again, I don't understand the education stuff well enough, but you know, it seems like grading is somewhat, you know, it's somewhat subjective at some level. I mean, whether, I don't know, you know, I just think if we had to change the rubric slightly because of a corner case, I think that's okay. But I think we should try to get these things appropriate for different levels of courses. And I would say there's a standard course sequence by grade level, right? So let's make sure we hit each of those in an appropriate way. Make sense?
Okay.
All right, good stuff. Okay, I mean, this is going in a good direction. Thanks. Okay, bye guys.
Bye.